everybody, welcome to today's video about P Packet 2, the second video of the playlist practicing the SOAP examination. So today we're gonna work on 5 questions, which are 589, 497, 428, 381, and 373. So the plan is that I'm going to let you guys pause the video when you see the question. Think about the question for 5 minutes and see if you guys can figure out the answer, and I will talk about the questions. So let's get started. Okay, so let's talk about the problem. So this one, it's about the expected value. Okay, so more specifically, this is about the expectation of the total payment. Total payment. It's simply equal to the expectation of number of payments times the expectation of the amount of payment. Okay, and the question says that the number of payment is Poisson distributed with the mean 12. And the interesting thing is that we don't need to care much about what distribution it is. So in this case, it is Poisson, but it can be any distribution. As long as they tell me about the mean, then I don't need to worry much about it. So the mean equals to 12. And now we focus on the expectation of the amount of payment. So to understand how that works, we need to focus on the deductible here. So we have a deductible of 2, means that if the loss is less than 2, I mean less or equal to 2, the insurance company is not gonna pay for it. Because for most of the insurance company, they may have some policy that if the loss is too low, you can just cover this yourself. The company is not gonna pay for it. So this is what I mean deductible. If the loss is less than 2, then the company is not gonna pay. If the loss is greater than 2, then the company is gonna pay the exceeding part. So if the loss, if x is less or equal to 2, the company pays 0. If x is greater than 2, then the company pays whatever which is more than 2. So x minus 2. Okay, so this is what the deductible mean. So now let's go ahead and see if I can find the total payment. So the total payment equals to 12 times the expectation of the amount of payment. So notice that if the loss is less than 2, then the company pays nothing. So from 0 to 2, the company pays nothing. So in other words, I don't receive anything. So I can just write 0, which I don't need to write. So but then I need to maybe find from 2 to 8. That's where the company actually starts paying. So I want to write the corresponding probability down and the corresponding payment, which is x minus 2. So for each of the individual probability, the company is paying x minus 2. So we're basically solving for this integral. If I can solve for this integral, we can be happy because that's the question. That's the answer of the question. So let's see. Well, I can drag 32 out immediately because it's just a constant. And for the rest, it's just going to be maybe expand everything for a bit. I'll get 10x minus x squared minus 16 dx. Okay, and the coefficient here, I can divide 4 up and bottom, and I'll get 3 over 8. Very nice. And for the integral, well, so we all know how to solve for integrals because we're actuaries. So this is going to be 5x squared minus x to the cube over 3 minus 16x. from 8 to 2. Okay, so basically for the rest, it's just the calculator part. We just use the calculator, find the difference. So plug in 8 and plug in 2 and find the difference and multiply this by 3 over 8, I meant. And this is going to be 1305. And the answer is B. Okay, very nice. Let's move on to the next question. So let's again spend about 5 minutes on this question and see if you guys can figure out. Pause the video. Okay, so let's talk about the question. So this is about the exponential distribution. And the reason is that the form here, it's exactly the density function for exponential functions. Let's review for a bit. So for an exponential function, the density function, so let's assume x is greater than 0. So the density function, it's exactly theta below and e to the power of negative x over theta above, where theta is the mean. So theta is the mean. And okay, and the accumulation function, which is also the integral of the little f of x, which is equal to 1 minus e to the power of negative x over theta, where theta is also the mean. Okay, so the expectation of x is just theta, and the variance of x is theta squared, which can be verified by taking the integral from negative infinity to infinity and the variance by the definition. But we're not gonna do them here since but you guys are welcome to do this on your own. Okay, so in this case, we see that the density function is like this, indicating that theta equals to 6, and that's the mean. And we know that x, y, and z, they are independent random variables which can be modeled by the exponential function with the mean of 6. So this is what I know. And the question defines w to be the minimum of x, y, and z. So this is sort of interesting. And we want to find the expected value of w. So to understand how to do it, I just need to try and find what theta equals to and see if that will... Oh, so actually I need to show that w is it's indeed an exponential function as well. And if I can do that, then I can just find what theta equals to for w, and that will help us to finish the question. So it turns out that w is also one exponential function, and I will show you why. So let's assume that maybe s bar. So I just want to make a distinction between the... Oh, I didn't talk about the survival functions yet. So the actuaries, they invented a survival function, Sx. Basically, this function measures the amount of area on the right of some specific point x. And this is going to be simply the complement of fx. I mean, this fx. So that would be e to the power of negative x over theta. And okay, so let's assume, so we don't know whether w is exponentials yet, but we're gonna show that it is indeed an exponential function. And how do I do that? Let s bar be the survival function of w. So basically s bar x equals to the p of w greater than some little w, some value w. And notice that what w is, it's simply the minimum value of x, y, and z. And what does it mean that the minimum value of x, y, and z greater than w? So if you guys noticed, this means that all of x, y, and z must be greater than w. So the probability of x greater than w, y greater than w, and z greater than w. And since x, y, and z, they are independent. So this is where we're using the independent here. Since they are independent, then this means that I can split the probability. Oh, sorry about my horrible handwriting. Okay, and notice that this is exactly their survival function, S. So, oh, I mean SW times SW times SW. So basically, that's exactly their survival function. And since their survival function are the same, we're just gonna square that. So there's it's going to be e to the power of negative w over 4. Oh, sorry, w over 6, I meant, to the power of 3, which makes it e to the power of w over 2. And notice that this is the survival function for the w. And this looks really like another exponential function because we know that the exponential functions have the survival function in forms like this. And since the 2 here, it's at the place of the theta, then theta equals to 2. And that's the mean of w. So because of that, we can solve the question immediately. The question, the answer is D. Okay, so let's go ahead and do the next one, 428. So let's again spend another 5 minutes, pause the video, and let's go. Okay, so let's talk about the question. This problem, it's about exponential again. So because I see an exponential is here. So again, let's review. Since it has the mean of 7.2, the accumulation function f of x equals to 1 over e to the power of negative x over the mean, which is 7.2. And the density function will be 7.2 in the bottom, and also e to the power of negative x over 7.2 in here. So now the question is asking that any chip which fails, the density function models the probability of failing in that specific year. And the problem is saying that, well, if I replace any chip that fails within, so the within here stands for less than, that's or equal to. So within t years, so basically, if the chip fails in t years, exactly t years, or any year less than t years, it's going to be replaced. And that amount is exactly 5% of all chips. Well, then basically this means that if I look at its accumulation function and I look at the area on the left of the t, it must be exactly 5% of everything. So that gives us ft equals to 0.05. And then we can solve for t now. So 1 minus e to the power of negative t over 7.2 equals to 0.05. Which means that e to the power of negative t over 7.2 equals to 0.95. And we're basically solving for this. And how do I solve for this? I take natural logs on both sides. And by the properties of logs, I can bring the exponents in front. So negative t over 7.2 will equal to log 0.95 over log e. And by the way, log e is just 1. So, um, okay. And we can use a calculator for all the tedious stuff, and I'll get t equals to 0.369 as the answer. Okay, so that's the problem for 28. Okay, let's go ahead and do the next question. Let's again spend 5 minutes on this and see if you guys can figure this out. Okay, so let's talk about this. So this problem is about conditional probability. Conditional probabilities. And how could I tell? Well, I see an given net. So basically, when we see given net, this means that we're computing for a conditional probability. Okay, so let's read the question. So we have a probability density function for a lifetime of a car. And basically, we want to find, so what do I want to find? The probability of the car's lifetime is less than 20 years. So maybe we can use, x to be the lifetime. So we want to find p, x is less than 20. And let's assume that the unit it's about years. Given that the lifetime is at least 5 years, so x is greater than 5. Okay, so this is what I want to find, and we know that x is modeled by this probability density function. According to the definition of conditionals, this equals to p of x greater than 5 in the bottom, and the probability of x is less than 20 and x is greater than 5. I can rewrite that a little bit so that things will make more sense. So x is greater than 5 and less than 20. So this is what the and here means. It has to satisfy both inequalities. Sorry about my horrible writing. Okay, so we're basically doing finding that, and well, this simply equals to, oh, let's see. So we're not gonna compute for, so we're not gonna compute for from 5 to infinity here. Because that's again doable, but there are easier ways to do. So basically, instead, I can just use the complement and subtract it from 1. So from 0 to 5, fx dx, and for the rest, it's just from 5 to 20 fx. Oh, I think I forgot to wait, let me see. Well, good. Oh, yes, fx dx. Okay, and this is our fx, since everything here it's greater than 0. And so basically we just need to solve for this integral. So if I can find the integral of this, I will be everything I can just calculate to do this. So all the things left, it's about doing this integral. And since we found that, wow, we have some similarities here, maybe we should try and do an u sub, and we can cancel something out. So u sub, that u equals to 0.0625x, and du equals to negative 0 dx. And now we can replace x by u, and this is going to be negative. So basically I can I can divide, divide the same thing here, and this will be e to the power of u, du. Okay, and this is simply going to be a negative e to the power of u plus c, and now I can drag everything back, negative e to the power of um, negative 0.0625x plus c. Okay, so just a little bit of calculus here, and which means that the whole thing here now can be computed. So this is going to be negative e to the power of negative 0.0625x from 20 to 5, from 5 to 20 I meant, and the same here. So negative e to the power of negative 0.0025x from 0 to 5. Okay, and just use calculator to do that, and I'll get 0.4451 over 0.7316, which equals to 0.6084. Okay, so the correct answer is C. Okay, very nice. Okay, so I think there's one more question. Let's go over that as well, and that's the last question of the video. So let's spend about 5 minutes, pause the video, and let's see if you can handle this. Okay, so basically this problem is about joint probability again. And the reason I say this is a joint probability is that this is a probability function with two variables. Okay, so the question is basically asking for the variance of x. And in order to find the variance, we might need to find the expected value of x and some other things about x. And the only thing matters is that we don't focus on y, we only focus on x. So basically, we don't, as long as we have the same x, then we don't make the distinction of what y equals to anymore. No matter what y equals to, we treat them as the same thing. So let's do a bunch of computations. So we know that f of xy equals to x plus y plus 2 over 36 for many possibilities here. So for 9 possibilities here. And for the others, they must be 0. So let's see. So let's firstly compute for when x equals to 0 and y equals to 0. And this is going to be 1/18th. When x is 1 and y is 0, this is going to be 3 over 36, which is going to be 1/12. And I can do the same thing here. 0, 1. When y is 1 and x is 0, I get 1/12 because of the same reason. And let's do 2, 0. When x equals to 2 and y equals to 0, this is going to be 4 over 36, which is 1/9. And same here. Okay, and when x and y both equals to 2, then I'm getting 6 over 36, which is 1/6. When x equals to 3 and y equals to 3, oh, I think I need to, sorry, I think I made, there's not really a 3. I should have put my 2 and 2 here. Yeah, sorry. So, okay, so when they both equal to 1, yes, that's what I was asking. This should be 1/9. And when x is 1 and y is 2, oh, maybe I should do 2 and 1 because I want to make everything organized. So when x is 1, when x is 2 and y is 1, I'm getting 5 over 36, which cannot be simplified. And I'm going to do the same thing here. So if you want to add the 9 possibilities together, then I think we were supposed to get 1. But we're not going to do that here since that's not the main point. So the main point is that these 3 things corresponds to the total probability of x equals to 0. And these 3 things are about x equals to 1. And these 3 things are about x equals to 2. So let's just compute for their probabilities by combining them together. So Px equals to 0 equals to 1 over 18 plus 1 over 12 plus 1 over 9, which I believe will give us the 7 over 6. Okay, and Px equals to 1, add these 3 probabilities together will give us the answer of 1/3. And finally, Px equals to 2 equals to 5 over 12. Okay, and again, if you add these 3 things together, you are supposed to get 1. So on the exam, if it is easy to check, feel free to check so that if you make some mistakes, you are able to catch it. So now let's go ahead and find the expectation. So the expectation of x equals to, by definition, 0 times the corresponding probability plus 1 times the probability plus 2 times the probability. And this gives us the answer of... Oh, sorry. I think the 7 over 6 should be here. Sorry, the original probability for x equals to 0 should be 1/4. So I should have add them up and see if I get 1, and so that I can catch my mistake. So I didn't do so. But okay, so this is 1/4. So this should be 1/4. Sorry, I made a mistake. Okay, so we find the probability, and now let's get the... Oh, sorry, not the probability, the expectation. So now let's find the expectation of x squared. So this is going to be 0 squared times 1/4 plus 1 squared times 1/3 plus 2 squared times 5 over 12. And this is going to be just, this is going to be 49 over, sorry, not, this is just going to be 2. And if I square this is going to be 49 over 36. Okay, and now we have the 2 components for the variance. This equals to e to the power e time, the expectation of x squared minus the square of the expectation. And that's going to be 2 minus 49 over 36, which equals to 23 over 36. Okay, so maybe use a calculator to do that. This will be 0.6389. So the answer should be B. Okay, so thank you very much for doing today's practice section, and I'll see you in the next video.